Okay, let's go over the quiz from today, tomorrow when you take the quiz, or today when you take the quiz actually. It'll be free response. You're not going to get an answer bank or anything like that, so make sure you memorize these. All right, so let's go through. I'm going to start at 7, and then I'll work my way to the conservation momentum problems. All right, let's see. Okay, this is just a straightforward problem. This is, bam, impulse momentum theorem. Best answer is B, reduces the force by increasing the time. Isolated system, 0 forces. Closed system, no loss or gain in mass. All forces in an isolated system are internal. What is the magnitude of the force, the forces exerted by each ball? They're equal. That's Newton's third law. All forces are equal and opposite. Law of conservation momentum. You have to be specific. In a closed system with no external forces, this does not change. Linear momentum is A, product of mass and velocity. Remember, product is multiply. J stands for impulse. Remember that, Jim pulse. Impulse momentum theorem states A, the impulse of an object is equal to the change in momentum it causes. Symbol P stands for, that's right, momentum. Impulse is the product of, okay, force times time, change in time. And the net external force in a system is 0. It's described as an isolated system. Okay, two objects, one is 1 kilogram, one is 100. They have the same velocity. How do the momenta compare? Well, you have to do m times v for this one. You have to think of it in terms of m times v. This is momentum, right? Which one has a bigger momentum? I got 1 kilogram times 5 meters per second, 5 kilogram meters per second. Or you can do m times v with the second one, 100 times 5. So what's that momentum? That's 500 kilogram meters per second. Okay, so that one has more momentum. So object D has more momentum. Okay, but the impulse would be the same. The force would be the same. Okay. Name of a bouncy collision is a elastic. Name of a stuck together, a sticky collision, is called inelastic. Okay. All right, let's go back over to this side. See if I can get out of this transparent background. Okay, so these, you just got to balance out what's happening here. If, remember, these momentums have to add up to the same thing on both sides. So if I have a plus, and we're going to say right is plus, left is the negative direction, I have to have a balance of these momentums. So if I have a plus and a 0, I have to have a plus and a 0 over here. But since it's going to hit this ball, it's going to transfer its momentum over here. So this guy's going to have a 0, this guy's going to have a positive. Down here, a negative, positive. So these have to balance out somehow. They're going to transfer their momentum to each other. Negative, positive, so they're bouncing off of each other. And here, this is a recoil problem. You know, because there is no motion, there's no momentum at all. So the sum of the momenta is 0. So afterwards I have to have a sum of 0 as well. But since I have a momentum of object A final, momentum A final, since this is negative, I need to have a positive in order to balance it back out to 0 when I add them. Okay? So that's how that would work. Make sure you know how to do this. I might change it up a little bit on you. All right, study.